I'm actually watching this, how to make sure you buy the best driver for your swing video on Golfbidder. It's hard to believe we actually filmed this video over 10 years ago. So much has changed since then, and it's about time that we updated this. So over a series of 8 videos, what we are going to do is look at everything you need to consider when thinking about buying your next driver, be it a new one or a used one. We'll cover things like what modern drivers have that old ones don't have, why are drivers so expensive, and how things might change in the next 10 years. And actually, finally, we'll end on my 5 favourite drivers of all time. But right now, if you're in the market to purchase a driver, it is arguably the best time ever to do so, really, because the search for every gain possible, from the grip to the sole of the crown, has been zoned in on and improved by all the big golf companies to really seek out or eke out every advantage and get you hitting longer and straighter than ever before. So today, to start our mini-series, let's look at 5 things modern drivers have that old ones don't or didn't have. And I've got a nice sample here in front of me from some of the biggest brands to demonstrate. So let's crack on. Now, back in the day, there was only one choice, really. Once the solid metal driver head was glued onto the hosel, that was it. A driver either suited you or it didn't. We all remember the couple of swishes on the carpet being enough of a fitting to decide, well, this is the driver for me. Well, then the manufacturers thought we'd actually sell more drivers if we could produce one driver which would suit more players. We're not all the same. We don't all swing the club the same. We swing it differently. So there's no logic in assuming that one fixed-headed driver is going to suit all of us. And that is where driver adjustability came from. Today, you have drivers with huge amounts of adjustability, not just in the shaft and hosel, but also in the head of the club itself. Take the Sim 2 here. We can have its loft increased or decreased by degrees in seconds. The lie of the club can be made more upright with just a twist and the click of the adjustment wrench. Then there's the modern head itself. Take the Cobra Rad Speed driver here, where weight can be switched and interchanged to shift the whole center of gravity of the driver, to change the way it launches the ball, to change how much spin it puts on the ball. I can have the CG, for example, powered all the way up to the front with the weight forward for distance. Lower handicappers, better players might love this. Or it can be moved to the back to make the driver play more forgiving and straight, which will suit most other golfers out there. So other drivers then, like this Callaway Epic Flash, have weight in a sliding channel in the head running broadly from heel to toe. And depending on where you position this weight, you can set this driver up to hit draws, or you can make it hit fades. It is truly amazing and a feat of engineering to see just where modern drivers have come in terms of adjustability. And something tells me, we're not done yet. I'm actually old enough to remember when woods were actually made out of wood. Our persimmon driver was a thing of absolute beauty. And I actually recently played hickory golf, and that was a lot of fun. But driver heads then evolved from wood to metal to carbon. And now we have the top of the line drivers with multi-materials, metals and carbon, all seamlessly fused and working in concert together. And looking at, for instance, the modern Sim 2 here with its carbon crown and carbon sole plate fused with a steel face. There's this forged aluminium ring at the back, removable metal weighting. This is truly a multi-material driver, and you'll have your work cut out to find a weld or a join anywhere. It's seamless. But why are multi-materials used? Well, the idea is simple, really. To put carbon in the parts of the head where you need lightness, but also structural integrity, and then put metal, heavy pieces in the places you want to position weight, light, strong, and essentially springy pieces in the place where the ball strikes the face. You might then have a carbon crown, a titanium or steel face, a heavier metal like tungsten or steel used to add weight where it is needed. Just looking at the Cobra rad speed here, you can see how carbon technology has advanced so much that it is now part of the design process. Like once upon a time, golf club engineers were driven demented trying to figure out how and where to design the weighting of drivers. Now they have almost a blank canvas where carbon is their friend. It's super thin yet super strong, and it gives them loads and loads of residual mass to place wherever they want. Advances in multi-material technology are arguably more impressive for me in modern drivers with minimal adjustability or only hosel adjustability, because the lack of movable weight tells you the engineers who designed and built this club think this is the best possible setup for the broadest range of golfers. Now, have you ever heard of a thing called iron Byron? Well, back in the day, first of all, a new prototype driver was made, and then it was tested by clamping it into a big mechanical swinging arm called iron Byron, and it measured how straight and how far it would hit the ball. 4 or 5 more prototypes might then have to be made, put into iron Byron, tested and tweaked. Weeks, months, years even of a designer's work would hinge on the prototypes made and the shots that this iron Byron machine would hit. Then computer-aided design came along, which helped streamline the design process. Driver heads got bigger, weighting improved, they looked way cooler, adjustability arrived, but there were hits and there were misses. Drivers that promised loads but nobody could hit. Other drivers that looked absolutely ridiculous really, but were functionally the straightest drivers ever. But now driver design has reached a point where artificial intelligence basically does all the heavy lifting. And it's Callaway actually who are at the forefront. We first saw AI in the epic Flash with its flash face, which was a result of thousands of these AI generated prototypes on the computer. It's braced by jailbreak bars and a carbon metal crown with the sliding weights. Altogether, it's a perfect package. Supercomputers can take all the variables like materials to be used, how much of them, their physical characteristics, their weight, how thin they need to be, blending them together, where the weight will go, how adjustable it needs to be, how it should look, the cost, the time, the waste, the labour, and loads more. And rapidly then produce thousands of iterations of a driver. And not only that, artificial intelligence can then predict exactly which of those iterations, when taken from the computer screen to the tee box, will actually perform best. All that work for something we simply want to use to hit a golf ball straight down the fairway and as far as possible. It is truly mind-blowing. Now, we really have been around the houses with driver head shape over the last few years, and this is something that we'll actually cover in much more detail in our next video. But no matter what tangent driver head has gone on, and it's gone on a few square, let's say, adventures, it has always returned to more or less the traditional teardrop shape. It's like when a customer walks into a butcher shop to buy a fillet steak. They expect that steak to look red and juicy and fresh. Not brown or black or aged. Even if that tastes better and is far more tender, it has to be red. That's what the customer wants. And even if funny shaped drivers work brilliant on the golf course, golfers expect the driver head to have a round or teardrop shaped head. So that's where we are. That's what sells. That's what the golfing customer wants. Now, most of us also know now that a driver head can have a maximum volume of 460 cc's, and engineers have to work within those constraints of the expected head shape and that volume. But how they work with both differs slightly from driver to driver. If you look at the Sim 2 Max, for example, looking down on it, it looks round and big and friendly, just like a driver should. You turn it over and you'll see all this incredible, imaginative and innovative weighting. TaylorMade call this an inertia generator. It combines advanced geometry and aerodynamic analytics, and that allows this driver to raise distance whilst having all that same straight technology of those square drivers that went before, and bring it to a whole new higher octave. Other designs are very subtle but hugely confidence-inspiring. Looking down on the Callaway Epic Flash driver, it's wider head, heel to toe, and shorter crown to sole, so it's really friendly looking behind the ball, but still on the limit of 460cc. Same with the rad speed. The step in the crown is nuanced. It's hardly even noticeable. But again, it's valuable cc's of volume that can be used to stretch the club head front and back to make it appear bigger. So bravo to the designers for giving the customer what they want. Now, I've been on many tour trucks over the past dozen or so years, and I've seen more than my fair share of engineers squidging glue into and onto drivers to tweak it, tweak the weighting, or even fix a dodgy rattle where a weight has come loose inside the driver, all to keep the professionals happy. And over the years, I've been to all the big production facilities where clubs are produced, assembled, and tested. And even 10 years ago, if you were in one of those factories producing drivers, you would be amazed how in a batch you might have 1 or 2 drivers that would suddenly have much hotter faces or better distance characteristics than all the others in the batch when quality control tested. And those clubs were often removed from the batch right there, and those were put aside and saved for the Tour Pros. Fast forward to now, and the level of precision and manufacture compared to even 10 years ago is like night and day. Advances in manufacturing techniques, their ability to produce materials to much tighter tolerances, to measure the same, to produce and to understand exactly the characteristics and limits of carbon and the vast array of metals and alloys used in modern drivers has advanced so much. You only need to look at the crown of the Sim 2, for example. Give it a couple of taps to appreciate how thin the carbon crown is, yet it will keep its structure and perform unerringly under load for its entire lifetime. Or look at the CNC milled face of the Cobra Rad Speed. So thin, yet so durable, right on the limit, incredibly forgiving, even if you miss this bit and hit that bit. And then think that every face in every driver is produced exactly the same. Then think about all the weighting in modern drivers and compare it to the squidgy glue on the tour truck. Precision manufacturing now allows thousands of a gram to be precisely positioned to make a driver perform better. It truly is exceptional. So there you have it. 5 things that modern drivers have that old ones don't. Some things you can see, like adjustability and materials. Some you can't, like artificial intelligence and tolerances. And some things you wanted to see, like a round head shape. Now, join me in our next installment where we will talk about how drivers have changed over the past 10 years. I've got some old ones and new ones. Year to year, the changes have happened subtly, but you will be amazed how far things have moved when you look at the progression of a 10-year-old driver to now. So that 10-year-old progression. Make sure also to hit like and subscribe to the Golfbidder YouTube channel if you enjoyed this video, and stay up to date with the very latest on Golfbidder, Facebook, Twitter and Instagram. For me, for now though, it's Donal, out.